So let us understand what are quadrilaterals and how exactly we define some of the terms. We see that there are four line segments joining each other, and by the way of these intersection between two lines we form four angles, and these four angles, the one that are inside the shape, are called interior angles. Okay, so we have four interior angles, right? Those are A, B, C and D. One angle at each vertex, correct? There is one property that applies universally across all quadrilaterals, is that called angle sum property. What this property says is that sum of all interior angles for a quadrilateral is equal to 360 degree, meaning the sum of angle A plus B plus C and angle D is equal to 360 degree. Now, in addition to these interior angles, let's say you extend the line segment AB a little bit further in this direction of AB and X. Now, the angle formed between the line segment AX with the line segment CB is called an exterior angle. Let's label this as angle 1. So, just like that, we could create four different exterior angles on this shape, right? Just like what we show in this diagram now, okay? Now, there is another property that also applies to quadrilaterals, is that sum of all exterior angles is equal to 360 degree. Okay. Now, this property is unique in a way that it does not apply just for quadrilaterals. This property applies to any polygon in general, that sum of all exterior angles for any polygon is equal to 360 degree. Okay. Now, with this universal property in mind, let us go take a deeper look at what is a trapezium and what is a parallelogram. Now take a look at these three shapes. There is a shape A, shape B, and then there is a shape C. Okay. There are some similarities and some differences between these shapes. So starting with the shape A first, if I were to label all the four vertices, let's say P, Q, R, and S, I notice that the line segment PQ is parallel to line segment RS, right? And the other condition is that line segment PS is equal to line segment QR. It is not parallel but equal to each other, okay? So such a shape in which you can find one pair of lines that are parallel to each other, then such a shape is called a trapezium. Alright, so keeping the same concept in mind, if you look at the shape B and let's say I assign some labels to the four vertices, let's say A, B, C and D. I can say that segment AB is parallel to segment CD. So with that definition, it is also a trapezium, right? That is correct. So if both of these are trapezium, then what is the difference? The difference lies in this specific condition that we have with shape A. It is that these two sides, they are equal in dimension, right? But in the case of shape B, which is also a trapezium, the line segment AD, the measure of this line is not equal to line segment PC. It is visibly different right here, correct? So this line is not the same as the line segment BC. These have two different lengths. So because of this difference, the trapezium A, in which the non-parallel lines are equal to each other, this trapezium is called isosceles trapezium. Now let us take a look at the shape number C. So in this case, I can say that line segment IJ is parallel to line segment KL, right? And likewise, I also say that line segment IL is parallel to line segment JK. And then there is one more condition. The condition is that the opposite lines are equal to each other. Okay, just like what we show in this diagram, that line segment IL is equal to line segment KJ in measurement, and so is the line segment IJ with KL, meaning this specific shape tells us that the opposite sides are equal and the opposite sides are parallel to each other. Okay, but the included angle between these two segments, between any two segments, is not equal to 90 degree. Okay, when these conditions exist, then such a shape is called a parallelogram. Okay, so you might wonder that if we can define a condition that if at least one pair of lines in four-sided shape is parallel, then we can call it a trapezium. So with that definition, we can say that a parallelogram is also a trapezium, right? But because of the unique properties that we see here, the opposite sides are parallel and the opposite sides are equal, it is given a special name, that is why it is called a parallelogram. Okay, now let us take a quick look at one example, that how we can apply these properties to solve some problems related to the measures of angles or sides. So with a simple example given here, we have that in a parallelogram, we know the measure of angle B. With that, we are supposed to find what is the measure of angle A and angle D in this diagram. Okay. Now, one condition that we find with a parallelogram is that because opposite sides are equal and parallel, that means the opposite angles will also be equal to each other. Okay. That means angle B is equal to angle D. We are already given angle B, that means angle D is also 60 degree. Okay, now let's try to find angle A. What will be that angle? You can find it in two different ways, but let's try the simple approach first. A plus B, all four angles, by the angle sum property, it should be 360 degree, right? And we know that A is equal to C, that means you can replace C with A, or in other words, twice of A plus B is equal to D, right? We just said that right here. That means twice of B is equal to 360 degree. Or in other words, if you divide both sides of this equation with 2, you can say that A plus B is equal to 180 degree, right? Now we already know what is B. That means angle A is equal to 180 degree minus angle B. That means 180 minus 60 degree, or angle A is equal to 120 degree, and that is the angle we can compute using this simple example. Okay, so in general, with the way of this one simple example, you could easily relate how the angles will be defined in any shape and how you can create different measurements. With that, now let us move on to our next concept of understanding a little bit more about a rectangle, square, and a rhombus.